What I'm going to talk about is adapting Simio projects to an online ODE course. And so in fall 2017, I actually incorporated several Simio projects into a traditional ODE course. And so this last fall, I used a similar approach, but this time the class was taught in an asynchronous online format. And so just like I did the first time, I wrote accompanying project assignments to help guide the students through the Simio projects. And I'm going to look at some examples and compare how they worked or didn't work and consider what we could do for future versions of the course. So since 1993, I've been teaching an introductory ODE class at Ball State. And the class is Math 374, and you can consider it a classic or traditional course based on the material covered as well as how it was taught. And so the first few times I taught the class, I used a book by Rainville, Beatty and Obedient. It's Elementary Differential Equations. And I found that this book worked very well. One of the main reasons is because each section has exactly one topic and the exposition is very concise and easy to follow and complete. About 18 years ago, we switched to Boyce and DePrima's classic book, Elementary Differential Equations and Boundary Value Problems. And part of the reason is textbooks are chosen by committee, and because we don't know who's going to be teaching the class. And I like the book a lot. It has a lot of extra detail to supplement class lectures. The only downside is that in order to match what I want to talk about, I had to have the students jump around in the textbook as we went along in the class. Now, this Simio has a bunch of free textbooks. There's resources that you can check out. And so I used a book by Jerry Level this last fall, which is really nice. It has a web version and a PDF version. It's free. And it's designed so you can plug in either Edwards and Penny, their book, or Boyce and DePrima. And so then I was able to use that instead of the book I used before. And a couple of times I used William Trench's free book that I also found at Simio's website when Level's book didn't have the stuff I needed to talk about. So what did I use as background material for getting into Simio? Well, I looked at the starter kit, and I looked at a sample course syllabus. I looked at a testimonial reflection by Rosemary Farley, and I went to a workshop at MathFest in 2017. So that was pretty much my introduction to using Simio materials for course. And so my plan back in 2017 was to choose projects that would align with the material covered in class. And I wanted to assign one project each Friday. It'd be due the following week. And they'd submit them they'd be due at midnight the following week. So I wouldn't assign projects during exam week or during the weeks with we had final presentations during the end of the semester, so we wouldn't have projects then. So I figured I'd be assigning about 8 projects, and this is before I'd done anything, so I didn't know how long projects would take, where we'd be each week. So here's an outline of the class for fall 2017. And so I have weeks on the left column here, and then what we covered, and then here's where I put the projects we actually assigned. So I assigned the ant tunnel building on week 1, and it was due the following week. And then we did M&M death and immigration, potato cooling, oil slick, the disease spread for M&Ms. And as you can see, the frequency of assigned projects decreased. So I learned that I couldn't do as many as I wanted to. So we ended up assigning 6 projects. This last one is one I made up, looking at a model for bubbles of beer rising in a glass of beer, where we looked at a paper and checked the details on it. So then here's a list of each of the 6 projects. So in the left column, I have what the project is, and then over on the right, sort of a brief description of what the project talks about. And I tried to match the project stuff up with what we were doing in the class at that time. And so, yeah, so you can just look at it. So as we went along, this is the stuff I assigned, trying to match again what we were doing in the class. So after the first Simiode project, the ant tunneling project, we did that in class and talked about, I decided to write up an accompanying project assignment. And this was based on our discussions in class. And the project was designed to help guide students through the Simiode project. And the stuff that's highlighted in red, that's stuff that was done in person in a classroom. And so here's the first project I wrote up. So it was read the handout, and then this was to help guide them to possible functions you could use to describe like how long it takes to build a portion of the tunnel. We had talked about those in class. And then then looking at a difference quotient, and basically we're trying to guide the students toward a differential equation. And so that's what was going on here. And then for my second project, this is a little bit more involved in the instructions I gave students. I wanted to read the handout. And then there's two experiments you do. There's one where you just shake out some M&Ms, and the ones that have an M facing up, those like die and you take them out. And then there's also one where you add some M&Ms back in. That's the death and immigration process. So I wanted them to do this in class and then record their data, and they'd be putting these into tables. And then the third thing I wanted them to do is an experiment where they chose a number between 6 and 16. And then they would use that as their number of M&Ms they'd add in after each step. And the idea was they were supposed to keep this number secret, record the data, and then share it with a classmate. Then the classmate would actually have to try to guess or figure out what is the number that was chosen between 6 and 16 for the experiment. And the stuff highlighted in red, that's what was done in person in the classroom. And then we also talked about trying to find functions to model the data we collected. And in class, we looked at the second experiment where we had death and immigration. And we came up with this recurrence relation here in class. And then I also pointed out that we needed to have a starting point. What are the initial number of M&Ms when we start this process at time 0? And again, the stuff highlighted in red is stuff that we did in the classroom. So then there was a series of guided instructions to help them work through the project. So we wanted to find a recurrence relation for the first experiment, and then make a table for the information for each experiment, tables 1 and 2. And then compare the model to the data they collected. You could solve using Mathematica, or you could use Wolfram Alpha. That was a suggestion I made. And then the next thing was solve the recurrence relation we found for the first experiment. And again, the stuff in red is what was done in class. And then they're supposed to repeat questions 3 and 4. So solve the recurrence relations by hand instead of using Mathematica's RSolve command. And then in the Simiode handout, there's a derivation of a differential equation for the second experiment. And you actually build an initial value problem. And I wanted them to solve it using Mathematica, which is suggested in Simiode. Then I also wanted them to solve it because we learned how to do that in class. And then I wanted to do the same thing for the first experiment, derive a differential equation, solve it by hand. And then go back and look at the data your classmate gave you, set up a model for it. And what I think is kind of neat is the last speaker chose like projects that I chose. So I directed them to a YouTube video I had found from a different Simiode project on using the solver to try to estimate parameters and minimize the sum of the square errors. And then they're supposed to build a table where they worked out their model, compared it to the measured data, and guessed the value of K that the classmate chose. And again, the stuff highlighted in red is what was done in a classroom. So what are the challenges for this past fall? Well, we had the pandemic, so that meant that a significant number of classes that we were teaching would be offered in an online format instead of face-to-face. Even typically they were face-to-face. Almost all the courses that we offered online had to be done in an asynchronous fashion. That was what we were told to do. And so we were also asked to have, I guess, required to have all meetings, including office hours, remotely. So we did not have any in-person meetings. And you could choose to have your exams proctored. There's a Respond This Lockdown browser that's built into Canvas. I did not choose that. Some of my colleagues did, but I set up online classes so that there was no proctoring involved. A lot of us had training for online over the summer. So my plan for fall 2020, I'd already run an independent study for the class in spring of 2018. And so I was planning to modify what I'd done for that course. Also, last semester in spring, halfway through when the pandemic hit, we all had to go online. So I had some experience with shifting to an online setting for a course. So my plan was to post approximately 2 PowerPoint lectures per week, and then there'd be readings or homework from levels text, and I supplement with other material as needed. I decided to post the same projects as we'd done in fall 2017, and I'd modify as needed. The projects would be posted at 8 a.m. on a Wednesday and due at 11:59 p.m. on a Friday, and usually I give them 2 weeks to do them. And the bottom line is I switched things so that 75% of the coursework in the class was take-home work, and there was a 25% was for like it'd be class exams. I had virtual office hours twice a week on Mondays and Wednesdays. I also met with students by appointment. And so I discussed projects mainly by sharing screens. So I did things through WebEx, which is just like Zoom. I shared screens with students. They showed me what they were doing. I showed them what I was doing, which is what I would have done during a normal office hour. Now, I didn't have any fancy equipment to like iPad or Apple Pencil or webcam. So what I did is I just used Microsoft Word and shared it, and I would type things like I would have written and to share ideas as we talked. I also used to talk to students about things on the projects. Okay, now we use Canvas as our learning management system for our classes, and so there's discussion. And so what I did for each project is I set up a discussion board with a question or hint, and I added more as was needed. And so I did this after the first project. So let's go back to the first project. I used ant tunneling, that project again. My initial project description was this, which should look very similar to fall 2017 because it's pretty much the same project. And right away, well, I realized that I couldn't use the same approach because students weren't in a classroom and they couldn't talk about stuff. We couldn't work together in a setting since the class was asynchronous. So what I did is I post some stuff to a discussion board. So I posted some suggested functions to start with, which we would have done in the classroom, asked if these were appropriate candidates for how long tunnel. And then after I worked with students on the project during office hours, I realized I needed to follow up with some more discussion. So then I stuck in an explicit hint for question 4. It was clear that the students needed some more guidance. So I put this in to hopefully guide students more carefully to what I hope they would get to. Okay, for the second project, this is the M&M project. Now, one of the neat things about this is, I guess it's fun because you get to shake out M&Ms. There's tactile portions to this project. You also get to eat the M&Ms. So, well, the fun gets removed when I can't give the students M&Ms and I can't expect that they can get M&Ms. I really liked in the last talk, one of the students they made their own M&Ms. Wasn't that clever? I would never have thought of that. So fortunately, there's virtual experiments. In Simio, there's actually a virtual M&M experiment. So there's a PDF slides where the experiment has been carried out. So what I did is I suggested you could use this if you didn't have M&Ms available. So here's the revisions to the project 2 for this last fall. And so that is the portions I revised because we were in an asynchronous online setting. So the red part is where if you don't have M&Ms, there's virtual experiments available for the pure death and immigration simulations. And then for share your data with a classmate, I took the role of the classmate and I picked an integer between 6 and 16 as my immigration number. And then this is data I recorded with M&Ms at home. And so I just shared this with the class. So then they all could work with this. And then this part here is where I'm trying to ask the students to think of functions to model each of the two experiments. These are recurrence relations. And so instead of in class, we would have come up with the recurrence relation for the second experiment. I told them what it would be. And then I also told them what the initial number of M&Ms would be. Now, if you use 50, then that the initial iteration at time 0, you'd have 50. If you use the virtual experiment, the initial number of M&Ms is 55. So I made sure to let them know that. So this part should look like what we had before for the project 2 from fall 2017. So a lot of this is going to be very similar. I'd say the big difference is just the part where I gave them the data for the third experiment. So that would be the main revision for the project. Okay, now for the initial discussion, I mean, I think this would have been clear in working in a classroom setting, but I put this in, to make sure it's clear that each M&M has an M on one side, and if you gently clear 55 M&Ms, how many are facing up? And then after working with students, I figured out that I had to put some more guidance or discussion in. And so this was to help them figure out, like, if you use the virtual experiments, how you should start setting up your tables. So I was trying to tell them, okay, looking at the slides, what should go on the table? So then I added some more discussion. I let them know there's a recurrence relation for each experiment. And then what should be the recurrence relation for the second experiment? What should be the recurrence relation for the first experiment? And and then I also indicated that if n is 0, these things work as well. Okay, so what are some of the adjustments I made for fall 2017 to fall 2020? So I have the projects listed here in the first column, the 6 projects, and then in the second column, I have what I did for fall 2017. So for example, for the ant tunnel, we had a class discussion building. And for fall 2020, I used Canvas discussions. For the death and immigration, we used M&Ms in class. We used virtual M&Ms for this last fall. For the potato cooling and oil slick, the main thing I did there is I just had to point them to Newton's law of cooling in our text. For the disease spread, instead of giving them a grid that they could take home and work with and M&Ms, there's virtual M&Ms experiments provided for that. Data to differential equations. That one I had to do a lot of discussion throughout the project because students were having some trouble with it, so I had to help them through that. This time I just posted a sample and detailed hints based on meetings with students. And for the bubbles of beer project, I provided hints followed by detailed hints based on work that the students had submitted. Again, I did this, I think, through postings in my Canvas webpage. So what have I observed for fall 2017? Well, one of the goals for students besides the mathematical concepts was the software needed. And students were more familiar with Excel. Most did not encounter the solver. Mathematica was a challenge. And that's typical for students in most courses where I use Mathematica. Initially, students struggled with the projects, but as the semester progressed, they got the hang of it. And I had to provide liberal hints, especially with the projects involving Mathematica. But overall, students seemed to do better in the class than in previous years. That's what I noticed. For this last fall, again, one of the main obstacles was the software needed. Again, they're more familiar with Excel. They hadn't heard of the solver. Mathematica was a challenge, just like before. One thing that happened this time is it seems that Wolfram Alpha was causing some problems. Students were picking to use that. And it seemed to me that in the past, if you typed a Mathematica command and Wolfram Alpha was able to handle it, But this time, some of the complex Mathematica commands, Wolfram Alpha wasn't able to interpret those. As students seem to struggle with the projects.
We're just running out of time,
Yes,
so just want to make sure you can wrap it up.
Yep, I have one more slide.
Excellent.
So students seem to struggle with projects not only initially, but throughout the semester. And that's kind of hard to gauge because with it being an online class and asynchronous, there's little or no interaction with approximately 75% of the class. I had to provide liberal hints, especially with the Mathematica projects. And one of the neat things is for this project 6, I came up with a method to minimize error in Mathematica, something none of my colleagues have ever seen, which was cool. So next time I teach the class, I'd like to still continue with SIMIODE projects. I want to spend more time on projects in class, maybe try video lecture ahead of time. And if it's online, I want to do it in a synchronous format. And if possible, I'd like to do it in a face-to-face setting. And here's some pictures of interactive learning spaces I might want to try. So that's the end of the lecture. Thank you.